something special about games that just make a man glued to the television, even if he's a grown man. Everybody, I'm David, and this video is brought to you by people who like to play games, like Angel. He's from Ecuador. He's pretty close to having his PhD in mechanical engineering, and today I wanted to dive into one of his PC builds because there's some new stuff, and I'll tell you our objective for the next, 40 minutes. Okay, I'll walk up close and just compare real quick, and then we're going to go to the lab. So this is the Lunchbox, okay, and then I'll go over to my office and I'll show you. So we're looking at a pretty small form factor. The idea to make this video is just because I saw him finishing his build on this and I was jealous. I'm thinking, boy, I always wanted the PC that runs the way I need it, but it's still small like this, and it was never very feasible until just nowadays. Okay, so now we're in this desktop workstation, and it's an AMD machine, and it's not. It's between $1,000 and $2,000 worth of equipment. Not super up to date, but definitely a custom build for mainly doing CAD was the most intensive task for this. And so just, side by side in our discussion, I'll give you a comparison of my experience with what we're going to show you there. And everybody don't laugh, but my graphics card right here is just a wimpy old WX 4100. Really not that old. I still purchased it only, I purchased it new a year and a half ago, because it was still the desirable option to bump up from what I had. Very good value and so compact, low wattage. So here we go. I'll introduce the purpose of the video. In the last couple of weeks, Angel was building his PC, just finishing up the last few components. I took an interest because I've built a few different computers, somewhere around like every 5 years, sometimes more for work. Back when I was younger, it was for play. And so it seemed like you pulled together kind of the best, latest components that you could get to build your own PC. And so there's a whole sweeping update that you could have if I think my audience is interested in building their own PCs. We did a poll. I put together this poll and we got 360 votes on. It was like, how long has it been since you last built a PC? And so this is my audience. It's we have 44% of us have built in the last 3 years or less. It was 16% have built within the last 8 years or less, and then 24% over 8 years ago. And so 10 years is not that long. The last 10 years kind of went fast. And certain pieces of information are still relevant, some are not. And then 16% haven't built one, but I hope to. And I don't know. Well, we'll come back into the comments in a moment. But okay, so share some novel information that was exciting to me, and then basically give just a conversation point. Okay. We'll pull out the thermal camera because you were just saying that.
Yeah, we were running the computer right now, like trying to run a couple of benchmarks and some engineering software. And the thing is that the design of the computer is such that all the heat all the air is pulled from below and from the sides and is expelled on the top. So if you can feel on the top, now it's warm, you can feel it. Yeah, and yeah. It was like way hotter a moment ago.
A little bit warm.
Yeah, but
it's cold on the left, like ambient, and then this is warm as well.
Yeah, so this one is the one that I wanted you to feel before, like few minutes ago, because this one was very, very hot. And this one was basically the same temperature as you can feel it now.
This is the intake side?
Yeah, this is the intake side for the processor and the power supply. In the other side, we have the intake for the GPU. So let me just take out
okay.
the panels for now, so I can show you a little bit more. So I am using here AMD motherboard, an ITX motherboard, a B650E/I Strix Gaming Wi-Fi motherboard.
Sorry,
So it's
which brand? Asus?
yeah, it's Asus. Yeah,
Asus. Okay.
so Asus, and it's a gaming ITX board, right? So it's a small form factor.
So the first change, I've never built an ITX computer before.
Yeah.
And it's always been, I looked into it a couple of years back and I thought, oh, okay, now that would mean either I lose slots of RAM and slots of PCIe, or I buy like the absolute most expensive
Yeah.
of some of those, like DDR5, and it was just borderline too expensive. And I think now we're at a better price point.
On this side, I am showing you the GPU. It is a AMD, is also an Asus. So it's an AMD 7900 GRE. So it's like one of the best GPUs from the previous generation, because the new generation was just released a few weeks ago, but this was the third best one that you could get, right? So I chose this one here because it has two fans that makes this like the shorter and most powerful, the shortest and most powerful one that you can get. Because usually all the other ones have three fans and they are like a little bit more than this, right?
Yeah,
so they wouldn't fit here.
This is funny because if I had this GPU, I would have, that would be the largest I've ever bought, because I never went full into gaming. So this is the smaller one you've had in the last few years.
Yeah.
So you're saying that the full power GPUs have...
Yeah, for instance, the 7900 XTX, it would be like around here, like 5 centimeters, like outside of the case, right? So it will be larger than this one here. So yeah, so this is the one. And the other side, I can show you the motherboard. So I am using this Noctua fan here. I changed this. I don't remember exactly the model for the cooler, but it's just using a 90 millimeter fan. That is a Noctua one. It came.
So, well, I want to make a note about that. That was exciting to me. You showed me that this was only under $40 for the cooler, all copper.
Yeah.
So this is pure copper, except in the tubes they have the modern technology heat exchange tubes that have a rough interface internally.
Yeah, heat pipes. Yeah.
Heat pipes, and so it has part fluid, part liquid. Sorry, part liquid, part gas.
No, well, it's a gas that it goes from the hot spot, becomes steam, so it can travel through the core of the heat pipe until like it reaches the colder part of the system, right? So when it reaches the colder part in the system, it becomes liquid, and because of the capillarity of the walls of the heat pipe, it returns to the heat spot, right? So it's like a system that is constrained inside the heat pipe.
Yeah. No, the awesome part was just that is fairly new technology, the way they've got it built into these chillers. You said, and then it's so low cost. Awesome.
This one is like the best one that you could purchase. I will give you the model so you can put that in the comments. But this one is the smallest one that you can get that can still cool down a 7800 X3D CPU. This is the one that I have here. So it was in the previous generation was the most powerful CPU. The new one, the 9800 X3D, was released just again like a couple of months ago. So this one is like at
I just want to show kind of the height. We're looking from my knuckle to my fingertip. My fingertip could almost touch the board, and so it's actually really slim. So okay. So you added your own.
I purchased it. Yeah, these are Noctua also the brand. They sell you these foams that the work that they do is that they create this tunnel, right? That is like against the mesh on the wall of the case.
So we want ambient air only to be
Yeah.
in this zone coming in,
Directly
rather than spiraling and mixing.
So
with
there are two benefits of having this tunnel. The first one is that it eliminates entirely the vibration, right? So because I have some fans that are installed directly against the lowest wall here. These make noise because these ones are like against the mesh against the wall here, right? So these produce some noise. I'm going to do. I watched a video recently, and I'm going to 3D print some kind of the same principle here, but just 2 millimeters thick. So that is going to improve the noise. Like you have to make the fan like at least like 3 or 4 millimeters away from the wall, and that eliminates the noise.
Okay.
Right. So that's what I'm going to try to do in this one here. But again, everything is like very well reduced here. So next step that I have with my build here is that this power supply cable is still too long for the build. So I'm going to create a customizable, like a custom cable here for this one here. So it's going to be shorter.
So you purchased a new harness that is built. It's offered by the maker of the power supply, not the motherboard, correct?
Yeah.
Then you're going to take that, snip it to the length that you.
Yeah, exactly. I've done that with several cables here. For instance, in the GPU, you barely can see the two cables here, right? But they are coming off in the back here. So if you can see in the back here.
Those are the extra power for the GPU. So. Back in the old days when I built a computer, then the GPU would get its power from the motherboard directly on the PCIe contacts. And now, so this is drawing up to 250 watts. So
it needs extra power.
Yeah, and those are still only just 12 volts, right?
Yeah, 12 volts. Yeah,
So,
but these two 8-pin cables.
Fun fact about, could you show us the harness,
Yeah,
the
so-
other side?
No, it's going down here. Like these two cables here.
They all mostly look
Below.
the same.
Yeah.
I just want to point out something on so all these pins on these motherboard plugs, many of those are only like redundant, multiple grounds, and a few of them are redundant of 12 volts. And so you get a total amperage that's higher than you could get with just one contact. Or the motherboard sometimes can decide to source that voltage separately and isolate something that maybe has a little bit more noise and a circuit that has less noise. Just the key point was when I dove into this, I realized that there are several wires with the same voltage.
Yeah, among the custom cables that I made, I even made these small fan cables, right? So I can just cut the long cables in the fan. You saw me doing that yesterday. Yeah. I cut the long cables in the fan, and then I installed these small ones here, like very short length in the fan.
So I will add these contacts. There's females inside of this housing, and there's a male right here. And those are exactly the same as the DuPont cables that we use in our robots and an Arduino stuff. So I'll pull out some examples just to show you. These cables can feel intimidating if you haven't done it before, but they're a lot more familiar than you think. It's only the housings that are really, the housings all look like different, they're specialized, but they're not too special. So this is a spool of DuPont housings. This is the female side. And those are, you'll find a few of these inside of. This gets bent off, okay, and then you have the contact. And that's the stuff that some of my other videos, I even showed the tutorial to crimp it. Whereas the male one looks like this, like just one of these, obviously. And then those slide into these multiple pin housings, however many you have. And then the ones for the computer, they just have extra features mechanically. For instance, you can see that rectangular area there the whole connection just does the same thing as our Arduino stuff, but it prevents you from accidentally plugging it in reversed, and just gives a little bit more beefiness of the material overall. So, okay,
Yeah.
back to your new stuff. You brought me this power supply that I don't know if you have two copies of the same one.
I have a, like, but that's for my second project.
Okay.
I've been trying to make external GPU with a NVIDIA 4060 low profile that I have. So I already started printing some 3D parts, and let me show you.
Okay, yeah, well, we can, set it aside until, the other thing is just the overall size of the power supply. That one, almost all of the common power supplies, like the one that I have, it's going to be all the way up to here.
Yeah.
The thickness, width, and length are all a little bit smaller on this one.
Yeah, this is an SFX form factor, power supply,
Okay.
SFX, right?
And the cost, these start at about how much price-wise?
Like 150 or something.
So call it time and a half if you want the same power level, but the small form factor, SFX, then call that time and a half the price.
Yeah. I also changed the fan. It came with a crappy fan, and then I put a Noctua also in there.
Oh, you actually pulled the cover off of.
Yeah, exactly. That's why you see the warranty sticker gone.
Yeah. Also, then earlier I asked you, like, how much effort was it to, let's say, because you chose all your own components, but this is not a spacious place. How hard was it to make it all fit, or to find out before you ordered the parts? Like, before I ordered this part, I know it'll fit in there.
Yeah. When you do one of these builds, you are going to fail a lot because sometimes you can just estimate the length of the cables, the amount of space that you have for several things. So I've screwed things up like several times with this one here. I wasted money in some things that I couldn't use eventually, right? So for instance, in this cable here, this PCI extender that we have here.
Okay.
So the previous ones that I got one that was too short, and then I got one that was too long, until I got this one here that is just perfect. It's like the previous one.
Extender?
Yeah.
Oh, okay. Well, I think I can point the camera down there.
Yeah, because the GPU has to be connected in the PCI slot, but
Okay.
yeah.
Let me zoom just a little. So what you have is the wing, the plastic wing here is holding a card that has the ordinary PCIe
Port. No, it's
male,
not.
the part that plugs in. And then what is this red thing?
It's just the cable. It's the
It's
extender.
moving.
Like it's a cable
It's
that is
point-
coming. You can see it. I hope that you can see it. Like it's folding and it's going on the back of the GPU, and it goes there.
Oh my gosh, okay. That's really. Oh, it's an S shape. So okay,
Yeah.
so this is where we wanted the port
Yeah, exactly.
to plug in the GPU, and it was pointed the other direction on the other side.
Yeah. Exactly.
Okay, so what I gathered is that it's from this direction. Ugh, I'm gonna just pick up the camera. From this direction, your slot was available, pointed right here, right?
I have to put my GPU like this,
So,
right? But
hold on. Yeah, okay. So you'd plug it in like
Like
that,
this, but-
and instead it plugs in here and then comes over motherboard, down and back
yeah,
up from like an S, even worse than one more term than an S.
yeah.
Oh my
It's
gosh.
called a double reverse PCIe extender.
So as far as would I attempt to do that if I didn't have loads of spare time or extra money, then we're still in the maybe territory, unless we can find a build somebody already documented on like PC part picker and said, okay, we got it all to fit for sure.
Yeah, you sometimes watch videos online and you see people using like all kind of extenders here. but this is the third one that I bought. That is the one that like finally fit like perfectly. It's not folded. It's not anything. It's just like it goes from here and reaches the GPU like perfectly, and it's 19 centimeters. Right, that's the length of the cable.
Gosh.
19 centimeters. Right.
Okay, so let's look and see what people said they commented on the poll. 6 hours ago, built mine just to be able to play and mod accounts on GTA 5, Grand Theft Auto 5 for people on PS4 and Xbox, was previously using a laptop. Built it when I was around 14, GTX 90, MSI Gaming M5. M5 is the motherboard model?
I think.
Yeah, motherboard. Sorry, he says motherboard here. i7 4990K, 8 gigabytes, Corsair Vengeance RAM to start, upgraded to 16 later on. Multiple moves with the military, not getting used for a while. Still turns right on and runs like a beast. Thanks for your service, Mr. Justin's Journey Reel. I miss all the computer stuff I used to have time for. Now I'm a 24/7 on-call roadside diesel mechanic. Well, the hands-on stuff is probably, I like that. I'm regularly opening up one of my computers to tinker with it. Right now, it's my NAS computer. What is NAS?
NAS. Yeah, I kind of remember.
We'll figure it out eventually. It's actually my job, so less than 8 hours ago. Love the content from you guys. Thanks. That's Chase Gallagher. I've learned a lot. Really appreciate the multidisciplinary approach to solving problems and reducing waste. Cool. Tyler Pastel. I used to be really into computers and built all mine from 13 years ago to 32. Helped others. I also worked in IT for the Air Force for 20 years. I'm loving that this audience feels like a whole span, like people ages like teenage to 45, and built my rig in 2020.
You're never done gaming.
Oh, me?
I mean, in general.
I've always
people.
just come close to gaming, and then I was like, I'll install a game and not quite get into it. Just the other day, I built my new PC and fixed up my girlfriend's. Way over 10 years ago, I fell into the apple cart and haven't been motivated enough to climb out. I feel that. How do you count if I haven't built a new system in forever, but I keep upgrading components every couple of years? Well, that's kind of exactly me. If I have a need that's not met, like a new software that's demanding something and I can't quite get the performance, then I'll go to upgrade. Or if something fails on the machine.
Also, that was my reason for getting this motherboard, because it still has some room left for improving, getting a better processor, better RAM, and also better graphics card. Yeah, so I think.
If someone was on a college budget, the part-time job, would you recommend going to use DDR4 or DDR5? Because DDR5 is like the ultra fancy, it's still really new.
I would recommend still DDR5 because DDR4 is almost gone.
Oh.
So, yeah.
I'm wondering what I have. I have the M.2. Well, I'd love to show you guys that, but I'm sure there's lots of PC experts. If you dive into any one specific component, that's the video. This video is not for that. It's just kind of a collecting people's thoughts together. Last comment, I found a smashed PC by the train. Some of the parts were not damaged and better than my PC, so I built one. They hated the heatsink, but didn't damage the CPU at all. They hated the heatsink. Not sure what.
Okay.
But yeah, thanks everybody that put in a little vote or a comment here. And I have a little story. So the last time I had to build a PC from scratch entirely, when I flew to Asia to live there in Malaysia, 2019, it was like December of 2019, I'm getting ready. In the very beginning of 2020, like January 1st or 2nd, I'm flying. I have a stop in Korea, and then I ultimately fly to Singapore, take a car to Malaysia. And when I arrived in Singapore, I had no computer anymore. And that was half of half of the stuff that I brought to live overseas. This was an unknown amount of time. It was turned out to be 12 months living there, but
without
like,
computer.
and I had just quit my job at the university. I had collected everything that I need, and certainly didn't have like a whole shipment container to bring stuff to do my life's work or whatever. And somewhere in this layover in South Korea, not somewhere, I had my 2 identical luggage bags, small enough for carry-on, and they were carry-on. I paid for carry-on all the way through to keep it close. One bag has exactly just my PC, nothing else. And then they forced me to, I'm groggy, I'm jet lagged and tired, and they said, well, here's the tag. We have to, as you board the plane from Korea to Singapore, they took it and said, we're gonna have to check it. And so I didn't fight it, and then never saw it again. And I have photos and I had records of keeping, but that was everything for me to have any purpose for the next coming months.
That happened the first day.
Oh yeah, and then so then I'm in Malaysia, and this amazing person wound up helping me. So I'm completely lost. Roads are backwards. I don't know the names of places. I don't know how to get around. I'm taking Ubers, and I go to the mall, and I'm on foot just wandering around the mall with a backpack to try to buy the pieces and build a new computer. And this gentleman helped me. Didn't have to do it at all, but anyway. I think it was called Meadow. Meadow was the name of the store inside this mall. And well, I'll tell a story about when this friend became like a friend. Now I was just texting him yesterday. He may come and travel to Texas. He's a fascinating Malaysian guy with a really cool story. He's a musician, and anyway, there was no way I would have got things figured out. I mean, imagine the very next day arriving there, I don't even know, I can't compute ringgits. I'm spending ringgits instead of dollars, and I have no idea if I'm overpaying for things, and so I desperately needed one-on-one help to make that happen. And yeah, so that computer, then since 21, coming back here, it's just had changes bit by bit all the way till now. So, thermal camera or something else?
I don't think the thermal camera would work right now. It was like when it was still hot.
Well, no, I mean, is there something that's worth seeing with the thermal camera? Or we can make a separate video sometime.
We can do that later on, or probably, we can play a little bit with fumes or anything, because I would like to see how the air moves inside. Because it's basically, we have 2 fans in the bottom that are pulling air like inside, and the direction of the fins in the cooler is also vertical. So any air that is being pulled from below is going to pass also through the cooler, like because of the fan on the bottom. Also, it's pulling air with this fan here. So like we have air from all directions going into the fins of the cooler.
But
and then
essentially, all of the fans on this side, and bottom are coming in.
Yeah, exactly.
And then
the only escape is on top. Yeah.
It's just the positive pressure inside. That would be cool to get a manometer in here and see how much pressure is in just this top zone that drives the air out.
Yeah, that's why we were gaming a little bit over there in the living room. When I grabbed the lunchbox, it was like super hot here, right?
Yeah.
And at the same time, I put my hand on this side, and it was cold. Right, so that's the nicest part of it.
Should be, it's working the way it's intended to.
Yeah, it's working the way it is intended to. Yeah, exactly.
The other reason, so I would just grab the thermal camera and show you guys just for fun, because it's fascinating to really see temperatures. But in a machine like this, you have so many shiny metal surfaces that have a different, what do you call it? Their reflectivity changes how the values show up on the thermal camera, and so it gets kind of messy, and it's not a very true picture. I don't know if that makes sense. But I'll cut here. Okay, these are just some extra components. Apparently they're not for this build, but they caught my eye when you were working with these in the last week. And I had questions that I think the audience also would benefit to know about.
Yeah, so first things first, this is the next project that I'm working on. This is a 4060, RTX 4060.
I'll come back over here.
Low profile. It came with this very noisy cooler. So I was thinking that probably I can improve it. And as a matter of fact, I did. So I used 3 Noctua fans and with some 3D printed parts that we made here.
Noctua is the famous brand for premium fans that go in PCs. They're quieter than the competition in general. They cost, I don't know, time and a half for a decent fan. And they have these weird colors. I don't like that. I'm not a fan of the colors, but here, I'll grab the camera and show some up close stuff.
Yeah.
So 60 millimeter.
These are 60 millimeters. 60 millimeters. Low profile because these are 14 millimeters thick. Normally they are 25, right? So.
But this one's
These are
special fans for the.
These are the cooler that came like in the graphics card, but this one is like very noisy.
So we enhanced the radius, the diameters of the fan, so you get more airflow, and then they're slightly more powerful, around 1.5 watts. And quieter.
Also, I used a phase change thermal paste there in the cooler, like between the CPU and the cooler, right? The GPU and the cooler, right?
So in this zone between the solid.
So now it runs like after doing this modification, it runs colder and quieter.
Nice. So the 3D printing situation was like 2.5 revisions of this plate just to get this super close to one another. I'm gonna tilt. Oh, okay. You got tape, so I can't.
Because of the cables, I use tape here. But it's 2 plates. One on the back. That is the one that is being installed against the cooler. You see here. These are.
So there's a threaded insert behind this fastener, M2 size or M2.5, and that insert sits. It's heat sunk into that 2 millimeter plate. So.
It's 4 of them. We used 4 of them, so you can see here another one, right?
Right
here
in this zone,
and in here the last one, right? So it's 4 of them. So we used these things. The back plate, the plate that is here, the 2 millimeters back plate here, is special because we have some part of the graphics card that is going inside this fan. So also this fan was modified a little bit so it could allow this protuberance inside the fan. You can see that here. So the fan is
kind of filing down a little section of the fan. Plastic housing.
Exactly. So that's basically the one. So now I'm going to use a cooling board that I already purchased. And then I'm going to use one of these power supplies that I have here that I'm going to show you.
So just to summarize, this whole unit is a GPU all packed together so it can be external to a computer. And so if you have mild computing power for your graphics, then you can plug this in separately and then do something high power gaming stuff, or maybe for a laptop.
Probably. That's the purpose of doing this external GPU casing and stuff. I'm going to do that the test with my laptop. We will do that later. But I'm going to use this power supply. This is a very well-known brand in the small form factor community. So this is a HD Plex, 400 watts.
This one was fascinating to me because it's a more compact power supply than I've ever seen available. And this sort of blurs the lines between power supplies for computers and power supplies for other industrial equipment. So the thing that makes this a PC supply is just the types of connectors that it has, really, right?
Yeah.
And
But
then no fans, so it's
yeah.
solid state.
Yeah, exactly. But well, anyway, this one here is going to need like a laptop power supply to provide the correct like DC current, right? Yeah.
What does it take in here?
You can. I think that this is for the same power supply that comes in an Alienware M18.
Well, so this is already, it's receiving DC to begin with?
Yeah.
Oh, this is not converting from AC.
No, but I have one here that does all the work, right? So yeah, because this is super compact. So this can go like this, but it still needs like a laptop power supply to provide some energy.
So just between the technology and the cost, I'll just break down one thing here. So in the power supply, you can get an inexpensive machine, sort of, that gives you fairly clean power at, let's say, 24 volts and a large chunk of amps, and it's cheap because it's only converting into one voltage. And then this is making that power available at multiple different voltages. The pins are, some of them are 5 volts, 12 volts, and I think 3.3 or something. So, and at the amperages needed for PC stuff.
Yeah. So now this is like the top of the line that I could get. So this is also an HD Plex power supply, but in this case this is like a complete power supply. This one doesn't need anything external. So this is a 400 watts ATX power supply.
And this one is this plugs into the AC power?
No, that one's, yeah. So that one comes directly to this.
Okay. Yeah, so...
Yeah. Like this, and this goes.
Then we have the familiar machine plug.
So yeah, so this one goes directly to the outlet on the wall, and then directly to the computer. So you can see how small it is. Right?
Yeah, that's super compact. 500 watts, yeah, compared with my power supply, that's as big as this section of the computer. And all right, so they're advertising gallium nitride, which apparently is the very micro technology inside of the converter, the transformers.
Yeah, exactly. That's why it's fanless.
And pretty efficient too, probably above 90%. So efficiency, meaning like if we're switching from AC to DC or DC to a different voltage in DC, then heat is lost at 10% of that power that's coming in, or less. Yeah, that would be about, how much is this thing?
$200.
That's pretty competitive. These should be, there should be more brands coming soon, I feel, because people are doing more tasks with that.
The main problem that we have in these days for these power supplies is that usually the cases that we can purchase don't come with the mounting holes. So probably you have to do some configure your own and stuff, right? So there's just one that I could find that could fit this one, right? Just one, like in the whole
case. You mean?
Yeah, a case. Yeah,
oh,
that could. Yeah, that you could put this one on.
Yeah. So that's even more motivation for
the game case C9. Yeah, that's the one that has the holes for mounting this one. That's the only one.
So if you get just a very basic training for yourself in CAD modeling, then you can start to use some of these components that are just not easy to integrate otherwise. Designing a simple plate like this one is very achievable now with, like, let's say, using a Fusion 360 online. If you're a high school student, you can self-teach how to build something like that. That's very approachable nowadays.
Yeah, because in this one it was this plate is the third iteration that we did in the same day, and in that
so we printed those on the
printer.
Creator Pro, and that was only like 25 minutes or less to make the print.
Nice.
So none of this is super high performance printing equipment. Everything is pretty.
Yeah, exactly. It was three iterations in the same day until that. After that, it was like, okay, this is it. This is the one. Yeah, and it works.
Okay. So what is it in this setup that would be hard to have if we didn't have the performance you've built up?
Yeah, of course. Right now, you can check that everything is maxed out.
Oh, you mean like frames per second and things?
Like here, you see, in the graphic options, everything is ultra ray tracing, ultra everything, right?
Is this one of those taxing games that's taxing for the...
Yeah, exactly. This is one of the newest games that you can have, and it still is running like perfectly, like a lot of frames per second. Of course, I'm using a little bit of DLSS, which is just some scaling resolution, but it's still like, let's just go a little bit different right now, and it still can give a like very good performance. Yeah. So the frames per second that you see up there, like 160.
Okay, regarding like shadows and fine details, what would I look for that says, oh yeah, I can tell this is a GPU intensive?
You see the reflections in the water. So this is with ray tracing activated. So you have all these reflections are calculated directly on the GPU. So you can see the people, how they are reflected in the water. You see, everything is, you can see that, right?
Yeah, for sure. I'm kind of zooming in on this.
Yeah, these guys are reflected in the water, like in
kind
real
of
life.
The sheen of his hair, of your main character's hair, is pretty noticeable too. It's kind of dynamic.
Yeah. So many things so you could see when you have like high lighting intensity scenes. You also can see the like all the shadows interacting between them, like in the water. Also, you can see the reflections how they work here.
Can you jump in the water?
I guess so.
Yeah. Oh, I like the swimming. That's pretty nice.
Yeah. So many things so you can. I found something here.
So how long till we could build a virtual copy, digital clone of the lab, the robotics lab with the parts inside of the lab, and gamify that?
I don't think that we are very far from for achieving something like that, because we have like a free software. We can use either like Unreal Engine that is on Epic Store, that is for free. You could also use Blender, that is an open source program. Like many people work in these games in Blender, so yeah, you can perfectly do. And now with all the AI stuff that you can see now, basically you can create 3D models from pictures, like
right.
So basically, I think that is not very far from being achievable now. It's just dedicating some time.
Are you able to identify any digital assets in here, like trees or stones, that have been borrowed from open source libraries of parts?
Not sure, but for sure that there must be lots, not just a few of them, like lots of them, because usually you can check several things like those.
If you're a very frequent gamer, would you ever like notice, I don't know, in the community, do people talk about, oh yeah, this really cool vehicle or something got copied from one game into another, or is it?
Yeah, between racing games it's easier to identify those things, because no one is going to model like a car like from scratch if you can just use a library, right?
Okay.
Yeah.
Oh, do you have a racing game?
I think so, but I think I don't know if I had it downloaded, but let me check. Yeah, I have lots of them, but I don't think I downloaded it. Yeah, I have.
So we're looking at Steam. If you're out of date like me as far as gaming, this is probably the most common platform where PC users are going to, like, you can download games from here. You can, I don't know what, set up, use Steam to set up the connection between other players in real time. Is that right?
Yeah, exactly. So this is like a community, right? It's a Steam community. So in here you can purchase the games, and then most of them are like for online gaming. Some others are not for online gaming, but basically it's like the way that you can have all your library to combine in some environment, right? So that's pretty cool. There are others like Epic Store, and I think that Apple also has the Apple Arcade store, but I think that the most famous now is like Steam. Steam is
And they support VR stuff too. Like if you purchase a VR headset, then you can download those compatible games here, yeah?
Yeah.
And then what about between different compatibility? I'm thinking if you have one kind of PC and a game, it used to be there would be a version released for, let's say, PlayStation, and then within a couple of months the same company would release the same game for PC. Is there any other I guess divisions between platforms that still occur, and you have to wait for a version of a game to come out?
Yeah, the games, depending on the developer, usually come first in the consoles, like either Xbox or PlayStation, or
like including this one here.
Yeah. So they come first there. Like after like a couple of months. Now it's a couple of months. Before it was like years. After that they were releasing PC. So now you can get them like after a couple of months. But it's still the consoles games come first.
When they release the PC version of the game, then can those players play, without question, can they play online together with the folks on the consoles?
Yeah. Most of them, yes. This is a cross-play game.
Okay, so they call it cross-play if that is possible.
Yeah.
Or if that's default, I suppose.
No, it's not default, but it could.
But on some games, perhaps it is.
Yeah, in some cases it's default.
Seamlessly. Okay, now we're loading Forza.
Yeah, Forza Horizon 5. So yeah, it's the last release for this franchise. Something that is cool right now, I would like to point out that now the computer is optimizing the game for the specs of the computer, right? So now it's like all the hardware is overloaded, right? Like the processor and everything is being like tested, so it could optimize the performance for this particular hardware. So you could see in the temperature in the final row of the specs over there. The temperature is reaching like 80 or something degrees.
Hold on, I'm seeing CPU temp 80.
Yeah, around 80 degrees, right? So that is really, really nicely achieved for a computer this size. Like all the cooling fans and everything that I put in the system are achieving that, because this is a 7800X 3D processor, an AMD processor, so it's a gaming processor, but it's like it easily reaches 90 degrees, which is the threshold of the temperature for the processor, and then it starts thermal throttling, so it reduces the frequency so it can keep up with the temperature change, right? So, but in this case, this is not even reaching the 90 degrees, right?
Oh,
so
90 is the threshold to throttle stuff?
Exactly, yeah.
Okay.
So now it's just around 80 in the part that was like the most loaded.
And you have the triple fan custom setup that you made last week?
Yeah, exactly,
okay.
Yeah.
With the Noctua fans. We're going to show that here a little bit later. I wanted to ask...
Okay.
So we had a little bit of, I saw a few frames that were kind of skipping or lagging. What
No.
was?
Yeah, right now, probably
FPS
the optimization.
7?
Yeah, with
Ooh,
the
so this is really taxing right now? Or?
yeah, it's a lot.
But is there a chance that so these graphics in the intro were not too heavy, but maybe something about pulling the data from the hard drive?
I don't think so, because the hard drive that I have in this computer is a Gen 5 SSD, so it's like super fast.
Well,
It's
what would be
faster.
the bottleneck when they're just pulling these? This is video, basically, right?
Yeah, this is video, yeah. But when we go to the gaming, probably I need to change a little bit of the settings.
So I'm looking at GPU at 35 watts. What's the peak now it's 41.
Yeah, the peak is 250.
Oh, sorry, no, GPU 1. What is the difference between those GPU 1 and 2 specs?
GPU 1 is the discrete GPU. And the GPU 2 is the GPU that comes integrated to the processor.
And it can use both simultaneously?
Yes, that's called, how is that called? Well, for gaming, no. For gaming, it's going to prefer the powerful, the most powerful one, right? But in general, the PC uses for like desktop activity the integrated GPU. But for gaming, it switches.
Favoring speed and shortest path to send the data in and out of your motherboard to, right? But now, what do you think is the bottleneck for when we get into gameplay? What is is the bottleneck more likely the GPU or one of the hard drives or something else? RAM maybe?
Let's see what is being the bottleneck right now. Everything is on extreme, so probably it cannot hold it. Sometimes this particular GPU is not very good at ray tracing, so why don't we turn that off and let's see how the performance is now. Okay. Let's see, no, it's still low. Just let me check what else we have.
You're just checking the overall FPS?
Oh, yeah. I'm trying to see what things we can edit so it can improve the performance. I think that graphics, we can take this a little, like one step down. In graphics, let's just don't go with extreme. Let's go with some, with ultra probably.
And what is the 99th percentile FPS spec up there on the top right?
Yeah, the 99% FPS is like, I don't understand this very well, but I will try to explain. So usually what you are shown there is the 1% FPS besides the FPS that you have on top. And the 1% FPS is like, it's trying to show you like the lowest
worst moments.
Yeah, worst moments in FPS.
Okay.
Yeah.
So my guess would be that we're claiming by giving you that spec, it's saying that 99% of the frames are being generated within this speed. And so if there's heavy glitches or nasty moments, then it's less than a percent of the time, then those may be.
Yeah, in the cases where you can see the 1% FPS, what they usually tell you is that the 1% and the actual FPS, they should be like very close to each other. So that ensures like fluidity in the gaming, right?
Yeah, that sounds like, to me, it sounds like consistency. Okay, and cut. Okay, we're back. So Angel just worked through an issue where the frames per second were up at like 9 or 10 and then wouldn't go up above 30 or 29. So the fix was to get the refresh rate on the TV bumped up from 30 hertz to 60 hertz, and then things started going. Cranked up all the settings back to
Extreme.
Extreme.
Hmm.
Okay, so in this video, it looks like we got some. This is the demo of the game. Actually, you're not playing right now.
It's the benchmark. It's the
Benchmark.
benchmark. Yeah.
Okay, so what do we look for?
Yeah, in this case, what is the computer is doing, like playing like a track that has like a lot of cars, a lot of public. You see people around. You have like depth in the environment, right? So you have a lot of geometry in the far like places, right?
Oh yeah, and the water accumulating.
Yeah, and
on the
also
window
water
screen.
reflections. You have like many things. You see also the water getting into the camera. So all these things are like cranking up all the power in the GPU. So I was talking to David before, like while I was trying to fix this, and I told him that this is one of the games that is the best optimized games that you can have in the market now. So I knew for sure that this is not like is not going to be like a challenge for this computer, right? So that's why I was like thinking that why is giving me just 13 frames per second? So something had to be fixed. That's what I was doing. So in this case, if you could see.
Oh, this is the results benchmark of the benchmark.
Yeah.
Okay.
So you see all that smooth line that they have on the right. So
Hold on, smooth climb. What do you mean?
the smooth line on the FPS.
Near. So we have the orange line at 60, meaning you were maxed out at 60, and it didn't have any.
Yeah,
drop
any
down.
any drop, right? So, I mean, if you could still see on the numbers on the right up on in the corner, you see that the GPU is just like in 50%, 55% utilization,
Oh.
right? So
I'm looking at GPU 1.
GPU 1
53.
utilization, yeah, 55.
GPU, and so GPU 2 is at 0, so that means it's not even being used.
Yeah, it's not being used.
Oh, that seems like on the first go around, we did have the GPU 2 being used. Am I right?
Yeah.
So there's something about when we had the TV limited.
Yeah, probably it was using the GPU 2 instead of the GPU 1, yeah.
Okay, but still, I don't know if I got the answer to the question of the GPU 1. What is the peak wattage that we would see?
The GPU 1, the peak wattage is around 250 when it's 100% usage.
Okay, and we're sitting around 160 right now. Okay.
Yeah.
68 degrees Celsius.
Yeah, and also this GPU is a 7900 GRE, so this is one of the coolest GPUs that you can get in the market. It doesn't get hot, like you can just give it like a lot of work and it's going to stay around 60 all the time, and you don't need a special cooling or anything. So that's pretty cool of this one.
So if we were doing, I don't know, intensive CAD tasks, is there any advantage to this, or you would only recommend this GPU for gaming purposes?
I've done like some SolidWorks work here, and it's pretty good one. Like I think that also for like a workstation, it would be very recommended, very well.
Is this for SolidWorks? Is this one the approved?
Like the certified
SolidWorks?
No, it's not, but you can have like a workaround, and I did it here.
Oh.
Yeah, I did it here. So I can show you in a moment. SolidWorks here. You can have like the real view activated. That means that it's certified.
Right. We'll have to explain that later, because that's a big deal. Getting just having the GPU utilized properly when I was running SolidWorks, it kept on trying to run a lot of my work on the CPU instead of the GPU when I was updating my stuff on my workstation. Okay, rolling. You explained that the real view graphics are, how does it go?
Yeah, the real view, well, first of all, the real view graphics is like this kind of rendery appearance when you are modeling in SolidWorks, right? It's not rendered, but
toggle it on and off.
Yeah, you can do that here. Okay, no, here. Hold on a sec. Let me do this one here.
Oh, those buttons look a little bit different than the last few years of SolidWorks.
Yeah.
Real view.
So here in view, real view, you turn that off, and that's how it looks, right? So if your GPU is not certified, it usually looks like this, right?
And you don't have the option to toggle that
Yeah,
on.
exactly. That option is grayed out, right? So
But
when
the interesting thing is, if you don't have real nice onboard graphics on your motherboard, then, or basically, you can make things even worse when you turn off the real view graphics because you're not allocating the processing to the graphics
exactly.
card.
Yeah, you can.
That's the trouble.
Yeah, you could activate this and make things like very badly, right? Like it could get like very slow and laggy. But since you have like, in this case, we have like a good GPU, I did the workaround and I kind of certified my GPU in the register in Windows, and then that's why I have access to the real view graphics.
I had no idea that you could do that. That's interesting.
Yeah, so now you have the same appearance that you usually have.
Beautiful. Okay, so I don't think there's a whole lot benchmark-wise to really show off on SolidWorks. So we were just going to quickly pop it open, and then now we can look at the hardware. Yeah.
Yeah, of course. Let's go.
All right.